Hello everyone, my name is Yasen and welcome to my tutorial on simultaneous equations. This is a topic listed in pretty much all the exam boards entailed in the national curriculum for the GCSE mathematics specification or syllabus. So we're having a look at linear simultaneous equations. So two equations at the same time that we use to solve with more than one unknown variable, and we use both equations together to solve for both unknown variables, unlike what you come across in the other videos or topics regarding linear equations where you have to solve for one unknown. In linear simultaneous equations you have to solve for two unknowns. So let's dive into it, I guess. So for this first example that we're looking at, we have, just like for any other simultaneous equation you'll come across, you have two unknown variables rather than one. They are x and y, and you have two separate equations here, but we have to use both together in order to solve for both x and y. So I've already labelled the top equation as equation 1 and the bottom as equation 2. So what I'm going to do, we have to try to somehow eliminate either x or y in order to solve for the other variable. So I can either eliminate x and solve for y, or I can eliminate y, solve for x, and take it from there. And then we have a method for solving the other variable. So for example, if I eliminate x and solve for y, then I use the value of y, substitute into either equation to solve for x. Or I could do it the other way round as well. Either method is sort of works the exact same way at the end of the day. You get the exact same answers essentially. So let's jump into it. So we have 4x plus 3y equals to 18 and x minus 3y equals to 7. So one method would be for me to eliminate x and solve for y, and that's what I'm going to do. A much easier way would be for me to just eliminate y and solve for x, but I'll show you that much later on after we solve through this first method here. So I'm going to eliminate x by multiplying the second equation by 4. So we are going to end up with 4x plus 3y equals to 18, and we're going to multiply this whole bottom equation by 4. So we're going to get 4x minus 12y equals to 7 times 4, which is 28. So this bottom equation is multiplied by 4. And now, as you can see, the reason why I've done this is to get the x's the same in order to subtract and eliminate the x. And that's what I'm going to do here. I'm going to subtract this second equation in order for me to eliminate x. So I'm going to subtract 4 by 4, which is 0. So we get that out of the way. We have plus 3y minus 12y, because we have another minus here along with the 12y. So 3y minus 12y, which by which two minuses make a positive. So 3y minus 12y is going to equal to 15y. So 15y equals to 18 minus 28, which is minus 10. And y would therefore equal to minus 10 over 15, which equals to minus 2/3. And this is how we've already solved for y. So we're pretty much halfway there, if I'm being honest, because now we just have to solve for x. So, for us to solve for x, I'm going to substitute the value of y either into equation 1 or equation 2. But either way, we should get the same answer by doing so. So just going to put another line here. I'm going to say sub y into equation 2. So we're going to have x minus 3 brackets minus 2/3 equals to 7. X minus, so we can obviously eliminate the 2 3's here. So we're left with x minus minus 2 equals to 7, which makes a positive. So x plus 2 is 7. X equals to 7 take away 2, which gives us 5. So we've solved for x, and we've got our value for y as well. So x equals to 5, and y equals to minus 2/3. I'm hoping everyone has understood this. If not, I'm going to, or just to clear everyone's mind as well in regards to doing things the opposite way round, by eliminating y and solving for x. And that's what we'll do here again. And it always should lead us to the same answers as what we've just got now. Obviously, if that's not the case, we've definitely done something wrong. Minus 3y equals, equals to 7. So again, this is equation 1, this is equation 2. So if we eliminate y, actually this is a much easier method, albeit a little confusing just because we have a negative here. Obviously, this is where the real problem sort of arises. If I subtract 3y by minus 3y, it's going to, if I just put another subtraction with a circle here, it will be 3y minus minus 3y, which gives us positive 6y. And that defeats the whole purpose of eliminating for y in order to solve for x in the first place. So instead, we can just add 3y to minus 3y in order to eliminate it altogether. That should be much simpler, since a positive and a negative makes a negative. So 3y plus minus 3y is going to be 3 minus 3y, which equals to 0. So that's gone. So we have 4x plus, so whatever you do to one side, you do it to all the other sides essentially. That's the principle for, the main principle for simultaneous equations or dealing with any algebraic equations. So we're going to do the same thing to the x's, so 4x plus x is 5x. 5x equals to 18 plus 7, which equals to 25. So we're going to divide by 5 on both sides. X therefore equals to 25 divided by 5, which is 5. So do we have 5 on what we've done on the other side here? We do. So we know we're doing something right at least. So I'm going to now substitute, so I can either substitute 5 into equation 1 or equation 2. Equation 2 looks simpler to me, just like what we did here. So I'm going to do that as well. So substitute x into equation 2. So therefore, 5 minus 3y equals to 7, minus 3y equals to 7 take away 5, minus 3y equals to 2, divide minus 3 on both sides. Oh, and there we go. Y equals to minus 2/3. And we have the exact same answer as what we're given here. And the same thing applies to x as well. I'm hoping everyone has understood this. And let's try and have a look at another example here. Let's have a look at our second example here. So things look slightly more complicated compared to what we saw earlier, but again the principle is no different, but we have to perform a few extra steps in order to get our final answers. So I'm going to still label this as equation 1 and label this as equation 2, just for the purposes of illustrating what steps we have to engage with in order to get the final answer. So, like I've mentioned, we have to allow both variables to work with one another on one side in order for us to solve for both of those variables. And there is a problem here. That's why it looks a little different compared to the first example. We need all the x's and y's on one side, and the values or just the plain coefficients on the other side. So equation 1 doesn't look like this, so we have to rearrange. So I'm going to put y on the other side. So 3x minus y equals to 9, and the second equation can remain the same as we already had the x's and the y's on one side. So x plus 5y equals to 5. So I'll label this as equation 1 and equation 2 just to reduce the confusion. Now, just like earlier, we're going to solve this equation as if we were following the previous example, so it looks exactly like what we could do in the previous example. So I'm going to multiply the bottom equation, so I can either eliminate x or y just like earlier. So if I'm eliminating y, I'll multiply the top by 5 in order for the y's to remain the same, and for me to eliminate x, I'm going to multiply the second equation by 3, which is exactly what I'm going to do. So 3x minus y equals to 9, 3x plus 5y equals to 5. And I'm going to subtract this whole equation in order to eliminate x. So minus y, so 3x take away 3x is nil. Minus y minus plus 5y, which is minus y minus 5y, because a plus and a minus makes a minus, of course, is minus 6y equals to 9 take away 5, which is 4. Y equals to minus 4/6, which equals to, I'm going to simplify this down, which is minus 2/3. So, as usual, I'm going to substitute y, or the value of y, into either equations in order to solve for y. So obviously we can have a look at what's going on here, since this is the rearranged equation. I'm going to still stick with substituting y into equation 2, maybe because it just looks a little simpler to me. So substitute y, and again, by doing it to either equation, you're going to get the right answer anyways. So substitute y into equation 2. So we're going to have x plus 5 brackets minus 2/3 equals to 5. So x minus 10/3 equals to 5. And the reason why it's minus 10/3 is because the plus and the minus makes a minus, of course. I'm just going to carry on from here, so I'll just put this in red this time. So x minus 10/3 equals to 5. I'm going to put minus 10/3 on the other side, so x equals to 5 minus 10/3. That equals, so 5 times 3 is 15, take away 5, sorry, 50, take away 10, equals to 5/3. And that's our final answer for x. So y equals to minus 2/3. Oh, that's wrong. This rub is really annoying. I don't know, something wrong again with Microsoft Paint that I have to look at. Anyways, excuse me there. Y is minus 2/3 and x is 5/3. So I hope everyone's understood the second example here, and now try to have a look at the last example, and then we're pretty much done for today. So this is our last example for us to have a look at for today. Again, it has that slight complication like the previous example, and it would have another complication that we're going to have a look at, like in the previous examples as well. Actually, sorry, unlike the previous examples. Sorry for the misnomer there. So this is equation 1 and this is equation 2. So again, we have to group all the unknowns on one side and the coefficients on the other side. So I'm going to do that all in one go, so bring that 4x to the other side in equation 1 and the 11 to the other side, and for equation 2 just bring the 1 to the other side. So that will be 3y minus 4x equals to minus 11. Oh, why did I do 10? That should be 11. And it's better for me to also match the y's with each other and the x's with each other as well to avoid confusion. So 2y plus 10x equals to minus 1. So I'm hoping everyone's understood that, especially after I've rearranged things into, in one go. So here's the other slight complication that we have. So in the earlier examples, we were able to easily eliminate either x by y by just multiplying only one of the equations by a certain amount, so that the other variable would look the same as the one on the other equation, and then you subtract the two somehow, or try to eliminate by either adding or subtracting. However, with this example, we can't do this. Instead, we're going to find the LCM of either variables to get them to be the same and then subtract. So this is pretty much what you've been doing when adding two fractions together with different denominators. So just a similar concept of finding the LCM of either y or the x's in both equations and then eliminating. So it's much easier for me to deal with the y's here since they are both positive. So the LCM of 3 and 2 is 6. So 6y. So I'm 6y minus plus. So whatever we do to one part of the equation, we have to do to all parts of the equation. And this happens to both equations because we've multiplied from 3 to 6 and from 2 to 6 by certain amounts. So for the first equation we're multiplying by 2, for the second equation we're multiplying by 3. And that's because to get from 3 to 6 we multiply by 2, and to get from 2 to 6 we multiply by 3. So this is the whole concept of the LCM, exactly what you've been doing when adding two fractions with different denominators. So I'm hoping everyone's following here still. So we have the top equation, so 6y minus 4 times 2, which is minus 8x, equals to minus 11 times 2, which is minus 22. And we're going to multiply the bottom equation by 3. So 10 times 3 is 30x, equals to minus 1 times 3, which is minus 3. And now it's much easier for me to just subtract, since both 6y's are positive here. So 6y take away 6y is nil. Minus 8x minus plus 30x, which is minus 8, minus 30x. It's minus 38x, which equals to minus 22 minus minus 3 is minus 22 plus 3, which is minus 19. So guys, I think for this topic, always really be careful with the negatives especially. They can really catch you out. So though you may have a good understanding of this topic, especially after you watch my tutorials, please take care with the signs in front of each of the values, especially the negatives. So going back to the question, we have minus 38x equals to minus 90. I'm going to divide both sides by minus 38. So obviously these two cancel. X equals to minus 19 over 38. We already know that 19 times 2 is 38, or you could just do this in your calculator. So much better to simplify, which equals to positive a half, because the two minuses also cancel out as well. So now I'm going to, sorry for the lack of space guys, so I'm going to substitute x, into, so I'm going to have a look at it here, either equation 1 or equation 2. I'm going to do this in equation 2, just looks slightly easier to me. So 2y plus 10 brackets a half equals to minus 1. So 10 times a half is 5, so 2y plus 5 equals to 1. I'm going to do this all in one go. So 1 take away 5 is minus 4, and if I divide 2 on both sides as well following this, it's going to be minus 4 divided by positive 2, which is minus 2. So the y therefore equals to minus 2. I'm hoping everyone's followed my reverberated explanation of this linear equation. Again, this is preliminary knowledge of solving linear equations, because this is a topic about simultaneous equations, so there shouldn't be much explanation at all in regard to this topic anyways. But if you are stuck with solving any linear equations, please refer to my previous videos on solving linear algebraic equations. So y is minus 2 and x equals to positive a half. I hope everyone's understood what I've gone over for today. If not, please leave a comment and just raise your query. I'll be more than happy to help you out. Or you could hit me up by email and just sort of raise any questions from there. I'm more than looking forward to answering all your questions or queries that you guys have in regard to the topic here at hand, or any mathematics topics within the GCSE syllabus as well. Please like and subscribe this video, and I'll see all of you in a bit. Take care.